Hello viewers, in our last lesson we discussed about similar figures. Can you recall what similar figures are? Similar figures have the same shape and their size may or may not be equal. So, that is a property of similar figures, that their shape is same but their size may or may not be equal. But now let us construct a quadrilateral. Now here is a quadrilateral and this quadrilateral has been constructed in such a way that this side is double of this side is double of this side is double of this, and this side is double of this. So here you find in a particular position the sides are becoming parallel to each other. That means this angle is equal to this angle is equal to this angle is equal to this one, and the fourth angle over here is equal to this one. But if I distort this constructed quadrilateral a little bit, now are they similar? No, they are not, because here the original figure is over here and the new figure is this. Here although the proportionality of the sides have been maintained, but the angles have changed. So that means for two figures to be similar, what is the necessary condition? The necessary condition for the two figures to be similar is that their corresponding angles are equal and their corresponding sides are proportional. But what about triangle? Triangle is also a special type of polygon with least number of sides. So if we talk of similarity of two triangles, then the triangles, what condition they will satisfy? Their corresponding sides will be proportional and the corresponding angles will be equal. Let us have a look at these triangles. Here one triangle is A, B, C, and the other triangle is P, Q, R. The correspondence is between point A and P, point B and Q, and point C and R. And we are provided that triangle ABC is similar to triangle PQR. Then what can you say about the corresponding angles? Now here, since A point is corresponding to angle P, so angle A will be equal to angle P. The point B is corresponding to angle point Q, so angle B will be equal to angle Q, and the C and R, they are corresponding to each other, angle C will be equal to angle R. So that is the one condition of similarity, that is the corresponding angles are equal. What will be the other condition? The corresponding sides will be proportional. Now corresponding to side AB is the side PQ. So the other condition is the first condition. The second condition is AB upon PQ. This ratio will be equal to BC, and the corresponding side to BC is QR, that is BC upon QR, and this ratio will be further equal to AC upon PR. So here we find that when two triangles are similar, the corresponding angles are equal and the corresponding sides are proportional. But the triangles are a special type of figures, and in triangles we look for the similarity by just looking at one of the conditions. That is, if we are given that the sides are proportional, then the angles automatically become equal. Now that speciality of triangles, that is, if one condition of similarity is satisfied, the other condition is automatically satisfied. Let us verify this by taking a triangle P, Q and R. Now here the sides of triangle PQR are, PQ is 8 centimeters, QR is 8.5 and PR is 7 centimeters. So if first I take a line which is twice of QR, that is it should be 17. So here is a line which I have drawn 17 centimeters long. And you can see that 17 is double of 8.5. Now I want to take the other side as 16. For this I will be using the protractor. For this I will be using the compass. Now here this is not 16. This is 16. Taking this as center, I will draw one arc. And to get a point corresponding to P, I have to draw another arc taking this as the center and opening the compass by 14 centimeter. This compass I have opened by 14 centimeter and we draw an arc over there. So these two arcs are meeting each other at this point. Let's name these points as A, this point as B and this point as C. Now completing this triangle, so here we get the triangle ABC. Now here the point A corresponds to R and R corresponds to A, P corresponds to B and B corresponds to P, and the point C corresponds to Q and Q corresponds to C. Now here once again see this, point A corresponds to R, point B corresponds to P and P corresponds to B, and the point C corresponds to Q, C corresponds to Q and Q corresponds to C. Now let us see the other condition of similarity, that is whether the angles are equal or not. So I will measure the angles of the given triangle, that is the triangle PQR. Here this angle Q is 50 degrees. Angle P is 70 degrees and the third angle is 60 degrees. The triangle which we drew it over here had the sides twice the sides of the triangle PQR. Now we have measured the angles Q as 50, R 60 degrees and P 70 degrees. Corresponding to point Q is the point C. Let us measure the angle at C. This is exactly 50. So this angle is 50 degrees. Now seeing the other point P. Now which is the corresponding to point P? Point P corresponds to point B and the angle P is 70 degrees. So what will be the measure of angle B? Let's see that. That's also 70. So here angle P, which was measured as 70, corresponding to point P is the angle point B. So angle P is 70 degrees and this is also equal to the constructed triangle, that is angle B. And angle Q corresponds to point C. The measure of angle Q is 50 degrees and this is equal to angle C. And for a triangle, you know that the sum of three angles is always 180. This we have already measured as 60, so this automatically comes out to be 60 degrees. So here what do you find? That the triangle I drew was having the sides twice that of triangle PQR and the angles which we measured after constructing the triangle ABC, they are corresponding to the angles of triangle PQR, that is they are equal. The angles automatically become equal, that is the corresponding angles automatically become equal. Now this kind of similarity where we are making use of the three sides of one triangle to construct another similar triangle is known as SSS or side similarity, and it states if the corresponding sides of two triangles are proportional, then they are similar, and this similarity is known as SSS similarity. Here SSS stand for side, side and side. So here we found one condition. Now can we think of any other condition where by taking one condition of similarity we can have the other condition? Now let's take that condition as we will construct a triangle with a triangle whose angles are already known to me. Here the triangle is ABC. And name this as P and this point as Q. Here the angle A is 100 degrees. Let me take the correspondence of A with P and make an angle of 100 degrees at A. This is 100 degrees. And taking the correspondence of point B with point Q, at B we have an angle of 40 degrees. So at Q I will make an angle of 40 degrees. Let's name this point as R. Now in this case I have taken the correspondence of point A with point P and P is corresponding to A. Then the point Q, its correspondence is with point B and B is corresponding to point Q. The point C is corresponding to point R and R is corresponding to point C. Now, here the side AB is this much. Now, corresponding to side AB is which side? It is the side PQ. Let us see that how much is that. So, PQ we see is twice of AB. PQ is twice of AB. Let us see the other sides. BC side has a length equal to this much, and corresponding to side BC is the side QR. So, here we find that QR is twice of BC. QR is twice of BC. Now remains the third side AC, and the side AC is corresponding to side PR of the constructed triangle. AC is of this much length. Let us see the side PR. So, PR we find is 2 times AC. PR is 2 times AC, and from here you can very well see that the ratio of the corresponding sides is same in each case, that is 2. The angles we had made 100, 40 and 40 degrees, and I constructed a new triangle with same angles as that of triangle ABC and got the sides twice that of the corresponding sides of the triangle ABC. So, in this one we found that if one triangle we have 3 angles are given and we construct another triangle whose 3 angles are same as that of the given triangle, then the triangles are similar. And this similarity theorem is known as, if in 2 triangles the corresponding angles are equal, that is the 2 triangles are equiangular, then the triangles are similar. And this we in short we call as AAA, that is angle, angle, angle similarity. Is there any other way by which we can see that the triangles are similar or not? Now, here I am taking a triangle LMN. So, here first of all I draw a line, and AB I have drawn is 10 centimeters. This point I name as A and this point I name as B. So, here A is corresponding to L and B is corresponding to M. A corresponds to L and L corresponds to A, B corresponds to M and M corresponds to B. Now, let us make an angle of 35 degrees at B. And I will take this side as 21 centimeters, being twice of 10.5. And then I join this point and we get a new triangle named as ABC. Now, remember once again that in this one I took AB twice of LM, and this angle at M is 35 degrees. I constructed this angle as also 35 degrees, and the side BC I have taken twice of 10.5, that is 21 centimeters. Now, let us measure the length of the third side. third side here is 7. This is 7 centimeters. And this one is 14 centimeters. So we found that here the third side is proportional to the third side of the constructed triangle, that is C is corresponding to point N and N is corresponding to point C. Now this is the one condition, that is we got the sides proportional, but let us see about the other angles. This angle is 120 degrees. So the third angle obviously will be how much? That will be 25 degrees. Now let us see the measure of angle A and that of angle C. Angle A is exactly 120 degrees, that is equal to angle L, and C angle, now this being 120 and this I have already constructed as 35, this will be 25 degrees. So here we took the side AB upon LM, they had the ratio of 2:1, and side BC upon MN, they also had the ratio of 2:1, and then we measured the side AC and we found that AC upon LN is also 2:1, and the corresponding angles have also been found equal, that is this angle L is 120 degrees and angle A is also 120 degrees, angle N 25 and angle C is 25. So when it was given that the triangles have two sides, this side was proportional to this side and this side was proportional to this side, and the included angle is equal to this included angle, the other conditions for similarity are automatically satisfied. We call this similarity theorem as SAS, that is side angle side similarity theorem, and this states if one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the triangles are similar, and we call this similarity as SAS similarity theorem. Now here we learnt few theorems on similarity. That is, in triangles we found that if one condition of similarity is satisfied, the other condition is automatically satisfied. Let us apply these theorems to some of the problems. This figure, it is given to me that angle B is equal to angle ADE. Here is angle B. This is given to me equal to angle ADE, and I have to prove that triangle ABC is similar to triangle ADE. Now since I am considering the similarity of triangle ABC and ADE, I will have to consider the correspondence of point A with A, B with D and C with E. You can see here that angle B is equal to angle ADE. This was already given to us, and in the two triangles ABC and ADE, this angle is common to both, that is angle A is equal to angle A, which is common to both. Then can you say that the triangle ABC is similar to triangle ADE? Yes, of course we can say that, because in a triangle the sum of angles is 180 degrees and the third angle will automatically be equal to third angle. So that means ABC is similar to triangle ADE. Now in this further question we ask you that what will be the measure of DE. Now since triangle ABC is similar to triangle ADE, that means AB upon AD will be equal to BC to its corresponding side DE, and this will be equal to AC upon AE. Now, since I have to find out DE, I will make use of this equality. Now, AB here is how much? AB is 8 plus 4, AE being 8 and this being 4, and AD is 10, BC is 9 units, and DE I have to find out. Let this be X. Now, if I solve it further, I get 12x is equal to 90, and from there you can find out the value of x, that is the length of side DE. Let us take another problem over here. Now, in this problem, AC is given to parallel to BD, and AB and CD intersect each other at E. We have to show that triangle ACE is similar to triangle BDE. Now, here that means if I have to show these triangles are similar, I will have to consider the correspondence between point A and B, C and D, E and E. Now, here let us see this. These triangles were given as, these lines were given to me as parallel, and here is a line which is acting as transversal. And you know this, that when two parallel lines are cut by a transversal, then alternate angles are equal. So, here this angle becomes equal to this angle, and here this angle E is equal to this angle being vertically opposite, and obviously third angle will be equal to the third angle, because the sum of angles of a triangle is two right angles. Even otherwise, because making use of the parallel lines, BD is parallel to AC and this is the transversal which cuts them. So, this angle will be equal to this angle as alternate angles. So, we find that triangle ACE is similar to triangle BD and E. Now, if these triangles are similar, then the corresponding sides have to be proportional, that is AC upon BD is equal to CE upon DE, and this is further equal to AE upon BE. But I am interested in finding AE upon CE is equal to BE upon DE. So, I will make use of this equality, that is CE over DE equals AE over BE, and by just simple shifting we can find that our result is proved. So, here you saw another problem where we made use of the similarity theorems to see that the triangles are similar. So, today we learnt about the similarity of triangles, under what conditions the two triangles can be similar, and applied them to some problems. In our next lesson, we shall apply these theorems to right triangles. Until then, thank you and goodbye.